right, so obviously we're still getting set up this morning, so appreciate everyone's patience. I would like to introduce Dr. Keith Schneider, a professor from the University of Florida. However, I'm unable to because he is unable to join us today. So I will be giving his presentation. Fortunately for all of you and for me, Keith and I work on very similar topics and actually have some overlap on some of our projects together. So this was an easy talk for me to jump in on. But we're going to be discussing this morning the effect of biological soil amendments of animal origin on the survival of pathogens in soil. All right. So forgive me if I start saying our or we. When I say that, I really mean Keith's group for most of these. But Keith's group has completed a bunch of studies examining the prevalence and survival of pathogens in these biological soil amendments of animal origin. And what I really like about this talk is, as Keith conducted one study, it would open up questions, and he just kind of kept building on those questions and answering them with subsequent studies. And so we're going to kind of discuss and go through his thought process and how his research has examined that. So he started out with looking at the content and survival of salmonella in chicken litter. He's looked at the presence and survival of pathogenic E. coli in bovine manure. And then has also looked at, when you introduce these into soils, how long do a lot of these survive? And really try to answer, are the National Organic Program recommendations sufficient? And we'll get into that in a minute, what we mean there. So if this acronym is not familiar to you, it's probably an indication you haven't sat through enough of our Produce Safety Alliance grower trainings. Our biological soil amendments of animal origin, FDA defines these as a biological soil amendment which consists in whole and part of materials of animal origin. So this can be things like manure, this can be our non-fecal based things like mortalities, bone meal, materials like that. It can also be table waste, alone or in combination. So if you take a little bit of this material and you mix it in with something else, that transforms everything into a biological soil amendment of animal origin. And so we're obviously concerned with these materials because we know foodborne pathogens are associated with them. FDA has been deferring action as part of their produce safety rule until they can conduct a risk assessment, until it's performed to determine an application interval for these untreated biological soil amendments of animal origin. So what this means is, if we have an untreated soil amendment, this means something that's not been composted. This is our manure straight out of the cow, or straight out of the animal, or our table waste that has not received any thermal process, any validated process to control pathogens. So right now, while FDA has not clearly said, this is how long you need to wait if you're going to spread chicken litter in your field, they do recommend that we follow the National Organic Program guidelines, which are the 90 to 120 day application intervals, 90 days if it is for a crop that the soil amendment won't be contacting, and 120 days where you might have direct contact with the edible portion of the crop. So if you have something like squash or cucumbers or things like that would be in contact with your soil, they recommend 120 days between when you apply that amendment that is untreated and when you harvest that crop. And so the idea is that you would get a natural reduction in pathogens throughout that 90 or throughout that 120 days, and reduce your risk of contamination coming from that material. But so that first line says, FDA is still waiting to make decisions, and they're still trying to collect research to determine if those intervals are adequate. So what Keith started out with were just a couple surveys of, all right, we know E. coli is in bovine manure, we know salmonella is in chicken litter, but how much of it? How often do you actually find it? Is this just a fluke? You go out sampling and you might find it sometimes, and they found in 25 farm visits, they actually found it 92% of the time. So they found it 92% of the time that they were visiting farms. They were collecting usually multiple samples at each farm from piles. So if you'd screen solids, or if you had it piled on someplace on the farm, they'd go around and they'd collect multiple samples from these piles. And so they found with these piles, usually it was in about half of piles at 56%, and about 18% of their total samples. Going to salmonella, they collected about 54 samples or 54 samplings, and they found it, or they did not detect it in about 40% of the samples they collected, but it was detected in one way or another in about 60% of salmonella, or of chicken samples. So all right, we've identified that it's there. How long does it actually persist? So there's been some research done looking at this, and we found that, some studies have found it can persist at 37 degrees Celsius for 42 to 49 days. You lowered the temperature, and it can actually survive a couple more days. This has been found in some other studies where, I want you to pay attention to this, where we get this increased survival as we start lowering our temperatures, or I guess we can reverse that. We get less survival if we start increasing our temperatures, and that's going to be important in some of his other studies going forward. Kim et al. Found that you could get survival, or the persistence of E. coli in some of these materials for up to 210 days. So if we're looking at that 90 and 120 days, there's already some literature that gives some recommendations here. We're going to see what Keith's stuff, what questions those answered. So the first thing they did is they were examining naturally occurring E. coli in manure by putting it in soil microcosms and storing it inside in controlled environments. And so they were using soil from 2 different locations, and as you can see, they were storing it at 2 different temperatures. So they had 30 degrees Celsius, that is our blue and red lines, and then 20 degrees are our green and orange lines. And as you can kind of see here, there really wasn't much of a difference from where the soil was from. The bigger factor here was our temperature. So our red and blue lines here indicate that at that 30 degrees Celsius, by about 200 days or so, they weren't detecting it in the soil. But at those 20 degrees Celsius temperatures, they were still collecting, or they were still identifying E. coli in these manure-containing microcosms out to about 400 days. So there was pretty extended survival. Now at low levels, so, and the thing Keith keeps putting on his slides throughout is low levels may not be clinically significant, but it is interesting to see that we still are getting this survival out here. As you can also see with this, by about day 50, we're getting this significant reduction, and we're really not reaching that point until closer to day 180, 190 for the lower temperature. So then they were looking at moisture levels and that impact. So we know there are multiple factors that play into the survival of pathogens. So there's a lot going on. You have your temperature, you have your sunlight exposure, you have moisture levels, you have naturally occurring microorganisms, which we'll get to in a second. And so what they did was they looked at pathogen survival in the sandy loam soil at 20 degrees Celsius, but at different moisture levels. And so what they found here was that at our 15% moisture, which is this green line that's kind of on the top, we got a delay in our reduction in those pathogen levels. So it seems like our higher moisture content, when we have that material placed in soils, that higher moisture content seems to extend the survival of some of these pathogens in these materials. So there are a lot of factors at play in the environment that impact the survival of these. So then some other work, they've been doing this work in the lab, now they're taking it out to the field, and so they created these little plots that were about 3 by 10 meters, and they amended them with cow manure. They then were tracking the naturally occurring generic E. coli that they knew was coming from that cow manure. So they knew how much they were kind of starting out with, and they were tracking what was in that and how long it survived, and they monitored it for 300 days. So for 300 days, a poor graduate student was going out to these plots and collecting samples in this poop-amended field. So what they found with this that was interesting, in their fall study that they conducted in Live Oak, so North Florida, they found that while they started out with relatively high levels, and so they had different levels of their starting material. So they did a light level of manure application, they did a heavy level, and they did a medium level. And they found that they got pretty significant reductions pretty much by day 30 or so. So really, really quick reductions. But what's interesting about this is throughout the 300 days, they got some persisters that would still pop up when they did sampling. So as we can see throughout here, particularly for the heavy and the medium inoculation levels, inoculations of this manure, they were still getting samples that were positive throughout the duration of the study. Again, are these clinically significant levels? That's a question. But out to 300 days, that's a big difference from our 90 to 120 days interval. They also examined this, let's see. They also examined or conducted the study in the summer months in Live Oak. So what is our big difference going to be here? Temperature probably is going to be a big one, although there'll be other factors. And what they found with this is, again, they got that really fast, I think I've got some arrows here. They got that really fast reduction, within that first 30 or so days for both of these. And the difference between these are our core samples on the left, and these are going to be our samples across the surface on the top. They got that really quick reduction, and there really was less of that level of persistence. So those higher temperatures in the summer tend to kind of reduce the number of persisters that were popping up throughout their sampling study. So really indicating that seasonality might play a big role, and you might have less risk if you're applying something in really hot weather or really hot months. And if you're applying in cooler months, over the winter months, for instance, you might still get some of those microorganisms persisting. So then Keith had the interesting thought of maybe it's not actually temperature that is playing the role in that reduction of microorganisms. Maybe that increased temperature is also increasing the metabolic activity of other microorganisms that might be in the soil. So maybe it's not just a direct relationship with that temperature reducing the survival of these microorganisms. Maybe warmer conditions are promoting just the natural microflora to have a more robust growth and outcompete this E. coli that they're looking for. So they wanted to see if there was a difference if they put these microorganisms in almost sterile soil, not exactly, but in clean soil versus just soil that wasn't treated. So what they did was they took some soil and they put it in an autoclave or a big pressure cooker. They did that 3 times, so it was almost sterile, not quite, but it had killed off most of the things in there, and they inoculated it with 3 different strains of E. coli. Then they took soil from the environment that was not treated, it was not autoclaved, so it had all those nice microorganisms that occur in it naturally. And they inoculated that with the same microorganisms, and they stored them next to each other at 30 degrees Celsius. And they found that in the natural soil, the populations declined much more rapidly than in the soil that received that autoclave treatment. I don't know if So really by day, I'm having trouble because I'm looking at an angle here. By about 30 days though, they had close to a 6 or 7 log reduction in that soil that had that natural microbiome in it, where you have your microorganisms probably outcompeting some of that E. coli that they've inoculated. At the same period of time, there's a much less significant reduction of only 1 or 2 log CFU per gram when they've removed all those natural microorganisms. So that kind of supported his theory a little bit on maybe there's something more going on with the natural community than just is it hot, is it cold, is our E. coli just being picky with temperature? So what they did, all right, we a lot of times say, E. coli and Salmonella are very similar to each other. They behave very similarly, and we tend to kind of go with this idea, and so they're like, well, we'll conduct this study and we'll look at Salmonella. So they took soil and they irradiated it to remove those natural microorganisms, and then they took the natural soil that has a microflora, and they found that Salmonella did not care. The reduction was pretty much the same at the same rates for both the soil that had no natural microorganisms and that wild soil. So just something to keep in mind. A lot of times we try to say things that control one pathogen also control others across the board, and this is a very clear indication that there are a lot of factors going on and our pathogens are behaving very differently. However, over time, they did get about a 5 log reduction within about 6 days. So now to touch on some current work. And so this is a project that I have actually worked with Keith on, and that Michelle Daniluk is the PI on the project. But we've been conducting these studies in onion, that's the word, in onion plots, both in Vidalia, Georgia, and we've been concurrently running it. Keith's group has been, again, at that Live Oak experiment station. And so what we've done is we've taken these plots and these onion fields and we've amended them with different types of poultry based compounds. So we have composted poultry litter, we have done the just unamended soil, and we've also looked at heat-treated poultry pellets. So we amended the soils, and then we inoculated them with a E. coli strain that we were able to recover, and we were just interested in seeing, all right, if you were looking at that 90 to 120 day interval in onion production fields, how long would it take for that E. coli to die off if you were amending it with a poultry-containing material? And so what was really interesting about this study, and I believe this is the live oak data, but I'll tell you the Vidalia data looks exactly the same. We got a pretty rapid reduction with our E. coli, with our control plots. So this is where we just put E. coli straight on the soil and didn't add an amendment. We got similar reductions with our poultry litter. So this is composted poultry litter that we applied to the plots and then artificially inoculated with E. coli. But what was interesting is throughout our 140-day sampling period, and one thing I want to explain is we were doing this to mimic onion production. So day 0 was usually around mid-November, and 140 was about the time that we were pulling those onions out of those plots. So with our heat-treated poultry pellets that we then added our E. coli to, we still had about 1.5 to 2 logs CFU per gram coming out of the soil with our E. coli. So something interesting is going on here with our heat-treated poultry pellets, and we're not sure exactly what that was about, but it happened consistently through 2 years of the study and at both locations where we were actually getting some continuing persistence of our E. coli in these amended soils. And as you can see, we're still having our survival out to 140 days. One interesting thing that Keith did after looking at this was he then took these same treatments and he put them back in those microcosms that he uses in his lab. And what they did was they used these same amendments, so the composted poultry litter and the pellets, and they added a few additional treatments. So typically you would add your chicken litter or whatever your organic material before you put your transplants in, but most production isn't going to see side dressing throughout the growing season of that chicken litter again. So typically what would be happening is the addition of synthetic fertilizer throughout the growing season so that you're not adding those pathogens to the material, but you still are getting that fertility need met by adding your synthetics. So what they found was when they added the blue and this kind of bluish green line are including, and I guess this green line, are all of our treatments that also have synthetic fertilizer. And we're getting within about 56 days this reduction where they weren't really detecting the E. coli as much anymore, where they were still finding it in these microcosms that had the poultry litter and the poultry pellets. So there seems to be some effect where synthetic fertilizers were actually kind of decreasing the persistence of these organisms in the microcosms in the lab. So just to leave you with a few implications, a few takeaways that Keith wanted us to discuss. Yes, we can find pathogens in biological soil amendments of animal origin. I don't think anyone is really surprised by that. We want these composted, but that's not practical a lot of times. It's extra handling, it's extra time, equipment, money. So we are interested in how long these can persist. Composting can eliminate these. And we're finding that some of our amendments can actually extend the survival of some of our microorganisms in soil. So that's something to be considering in part of a risk assessment that's being conducted. The big question I think that he wanted to leave you with is, do these levels matter? So are these levels that are actually going to be significant and could result in contamination of an end product and cause an outbreak? He has done some work where he has conducted these studies with onions growing in these soils. He's harvested them and they have gotten very low levels of this E. coli off of these onions. So, you know, just leave you with that question. I'm not going to answer it. I don't want anyone coming back and saying I said yes or no, but something to consider as you're conducting a risk assessment and deciding what materials to be using. So with that being said, are there any questions? Would you like to introduce yourself?
I can introduce myself. I'll introduce myself. I'm Michelle Daniluk. I'm at the University of Florida. Keith asked me originally to give the presentation that Laurel just gave, and I said, Laurel is doing this work with you. She would be much better to give it from you, and it would save you all from having to listen to me for an hour, which is a long time. So I'm going to talk today about harvester cleaning and sanitation. And the reason I'm going to talk about harvester cleaning and sanitation is because of this outbreak associated with Dole fresh cut lettuce and Listeria monocytogenes. And if you guys, 2021 into 2022 outbreak, are you guys, anyone in the room familiar with this outbreak? A little bit, maybe, yeah, some hands are going up. I want to take the microphone and walk over here, but I'm going to have to use the pointer, so I can't. A decade ago, when I used to come to this, maybe not a decade ago, I'll say that, 15 years ago, 18 years ago, when I first started coming to this meeting, we didn't spend a long time talking about Listeria monocytogenes on product, right? We were pre-outbreak in cantaloupe of Listeria monocytogenes. We kind of had some extension documents where we all knew it was there, but we never really talked about it. Well, now we're talking about it more and more and more, and this is one of our, not the most recent, but one of our more recent examples. And one of the reasons why we're talking about Listeria monocytogenes outbreaks so much more frequently is because of this thing called whole genome sequencing that FDA and CDC are doing when there's an outbreak. Instead of just looking at what we call the fingerprint of these microorganisms, they are now able to look at the whole genome of these microorganisms over long periods of time. And they were doing that all the time for isolates that they get into their collection. And so every once in a while, they are able to group together isolates over distance, so over many different states, and over time, over many different years, that all match each other, and then find a match in a product, and are able to then group them all together to call it an outbreak, right? And so this is an outbreak curve, what we would call here, of when people got sick. So it's, can you guys all see that line? Yep, that's a number of people that got sick. I want to point out this is one person getting sick, and this is two people getting sick. And then this is date that those people got sick. Now what you maybe can or can't see because it's pretty small, every one of these tick mark lines is January. This is January 15, January 2016, January 2017, January 18, 19, 20, 21, 22. So in January, or in late 2021, we had 2 cases together, and then FDA went back in and searched all their database and found matching Listeria without a lot of epidemiological data of what these people ate that matched this strain, linking them all together all the way back to 2014. Anybody in this room remember what they were eating in 2014? No, I'm not saying that these aren't all linked together. They are all linked together. These are the types of outbreaks we're seeing with Listeria monocytogenes, all right? And in this case, they took all these different cases, and so, right, they're separated by long distances of time. They're also separated by long distances of locations, right? So the light green states have 1 case, the medium green states have 2 cases, and then Ohio, our one blue state, has 3 cases. So they've been able to pull together all this data of outbreaks that happen, of cases of illness that happened over a long time, and because the whole genome sequence of these isolates was the same, they were able to group them together and find an outbreak. Now, what caused them to group them all together and find an outbreak is that states were doing sampling of retail products, and all state departments of agriculture, USDA, go out and do regular grocery store sampling of product. And when they now find positives for Listeria, for E. coli, for Salmonella in those grocery store products, they're allowed to get that whole genome sequence and then search all the way back in the database any cases that might be linked to that, group them all together, and we get outbreaks like this, right? So that's why we're seeing outbreaks like this. So I want to tell the story of this outbreak and then talk about why this led back to a harvester, okay? But this is happening now. We are going to continue to see this happen in the future. This is sort of the way public health is moving in terms of an outbreak. So Dole conducted a root cause analysis. FDA was doing a root cause analysis. Everyone was trying to figure out what went wrong. This is what triggered all that investigation into all those different cases. So October 2021, Georgia Department of Agriculture identified Listeria in a Dole brand salad as part of that routine monitoring that everybody's doing. All right, WGS, that whole genome sequencing, linked that Dole salad isolate to those cases I just showed you. That garden salad was processed in North Carolina. All right, so October 21. CDC opens an outbreak investigation. Michigan Department of Ag and Rural Development collected samples of packaged salads as part of their routine sampling. All right, and they identified that same whole genome sequence of Listeria monocytogenes in a market-side brand package of shredded iceberg lettuce. That iceberg was produced not at that facility in North Carolina, but in this case at the facility in Yuma, Arizona. Now, when you talk to a lot of us and we look at Listeria outbreaks, and especially Listeria outbreaks that happen over these long periods of time, our first thought doesn't go back to this is a field level contamination, right? When we see Salmonella outbreaks, when we see those STEC outbreaks coming out of the West Coast, we think field contamination event because we see a lot of sick people over a short period of time. When we see a Listeria outbreak over this long period of time, we're not thinking the same route of contamination. What we tend to think is in some facility, they've got a resident Listeria monocytogenes that every once in a while somehow gets onto product and then leads to this outbreak. And Elena's talking after me about sanitary design, and if you've got poor sanitary design, we can often find these resident pathogens in those situations. But in this case, we've got product coming out of two different facilities, both linked to Dole, that have the same Listeria in them. So our original thought where it must be a facility issue triggers us to say this couldn't be a facility issue because we've got product coming out of two facilities. So Dole did a fantastic root cause analysis, and if Natalie's in the room, and I don't know if she is in the room right now. She's not in the room. Natalie should, if you have any questions on what Dole did, talk to Natalie Deinson, who is now with the International Fresh Produce Association. She's talking this afternoon. She used to be with Dole. This is the work that her group did, and it's fantastic work. They actually went in and said, okay, what do those two lettuce have in common? They were checking their facilities. They were looking for Listeria, doing some fantastic Listeria, environmental monitoring, looking for it. What they managed to figure out was that the lettuce in those two different facilities actually came from the same piece of harvester equipment. And when they tore that piece of harvester equipment apart, they were able to find that outbreak Listeria strain on that harvester piece of equipment. All right, and I say on, but it's really like in the harvester piece of equipment. They really had to get in their swabbing to do that. And then they went ahead and recalled all of the products that had been run over that, on that contaminated piece of equipment. All right, this is the first time we've ever seen a harvester piece of equipment tied to this sort of a large, it's not a large outbreak, there weren't a ton of people sick, but this sort of a Listeria outbreak in this fashion. Now, this triggered FDA to say, maybe this harvester equipment is a problem. So last summer, I think June 13th, FDA put out this scheme where they said, well, we're going to go out now and sample harvesters, lettuce harvesters, to see how widespread this Listeria monocytogenes problem is on lettuce harvesters. Are you guys in the room aware of this assignment? Some people are nodding. Yeah, cool. All right, so FDA put out this harvester assignment in italics text. This is what they were trying to do. They are seeking to gain insight about the potential for human pathogens to persist on harvest equipment after routine cleaning and sanitizing and subsequently be transmitted to produce. They were looking at equipment used for carton-ready and process-ready leafy greens. They are not looking at any baby leaf at this point. They are really focused on heads. So equipment used for fully intact heads and then lettuce intended for processing. Very, very much focused on romaine. The way that they decided to construct this was they took 3 companies that had previously been associated with leafy green outbreaks. So I'm not going to name them for you, but certainly the company I talked about before was one, and some of our larger companies or others. And they went back to those companies and they said, we're going to do this sampling on your suppliers, and we're going to conduct inspections and do swabbing and sampling of these harvesters in Arizona, California, and Florida. All right, so I will tell you, we in Florida saw this come in and we thought, why are we included in this? Our lettuce production volume, right, is a lot smaller than what we see out on the West Coast, but here we are included in this. So this all happened in the summer. All right. They also said that when they pull those swabs, they're going to look for Listeria monocytogenes and E. coli 0157H7, that Shiga toxin strain associated with so many of those outbreaks. And they're going to do 36 inspections, and they're going to do 1 harvester in each one of these inspections. So I thought, of course, being in Florida, 36 inspections, okay, well, they'll do 1 or 2 in Florida, but no. In their infinite wisdom, they split it evenly between the 3 states and are going to do 12 harvesters in each state, which statistically is not the way I would design it, but I am not paid as much as the folks at FDA, so maybe they know something I don't. At each one of those inspections, they said they were going to collect 2 samples. Now, what they call a sample is not, I think, what most of us would call a sample. For them, each one of those samples were 64 environmental swabs that they collected on those harvesters. And so they collected them on zones 1, 2, and 3. So anybody in the room remember what a zone 1 is? Food contact surfaces. Zone 2 right are adjacents. And then zone 3 are a little bit further away than our adjacents. And so they are collecting these 64 swabs, and they're swabbing on 3 different zones, all 3 of the different zones, including food contact surfaces. FDA does notify the farms in advance that they will be included, or that they will have an inspection happen, and they have this time frame going from July 23 until March of this year. And the inspections actually, I think the first one happened in August of 23 out in California. All right, on these assignments, FDA will go out, and I said FDA and state because in California, Arizona, and Florida, the state departments of ag have been invited. It's up to them if they want to go as well. Can tell you in all cases they have chosen to go as well, but FDA and state will go out. So not only are they going to do the actual swabbing of the equipment, but they are going to include observation of the harvesting, and they are going to include observation then of the cleaning and sanitizing practice. All right, so they're going to go out and they're going to watch acres be harvested. They are going to then watch the cleaning and sanitizing happen, and then they are going to collect the swabs after that cleaning and sanitizing. Folks that have participated in this have been asked a lot of questions, not only about cleaning and sanitizing the equipment, but cleaning and sanitizing the tools used to do the cleaning and sanitizing, okay? PSR inspections are being done so the produce safety rule inspections are being done by FDA when they are observing that harvesting process. And if adverse findings are found while they're watching harvesting or cleaning and sanitizing, they will issue that 456 to say that they found something not right in that harvest process. Okay? And then, right, FDA and the state just observes, but FDA will begin to collect samples after the harvest, cleaning and sanitizing. Now, those 3 companies were able to negotiate with FDA that it would not be a full day of harvest production. They would harvest for 2 hours or about an acre of product before that cleaning and sanitation happened. The reason they did this is that no company in their right mind would want to put product on the market where FDA had come in and swabbed the cleaning and sanitizing equipment, right? So all the lettuce that's harvested on that first acre before the cleaning and sanitation and FDA swabbing happens has been discarded to date. None of that is ending up on the marketplace. But back to that 486 issue on the previous slide, if your harvest crew knows the product they're harvesting is not going onto the commercial market, sometimes they have been a little bit careless in their practices, which triggers some of those produce safety rule inspection issues. All right, FDA will then take all those samples that they've got. They will ship them, they will ship them to their laboratories, and FDA is doing all the micro lab work in-house. So they're not using a commercial lab, it's all happening in-house. And then harvesters will be notified whether or not they found any problems with their equipment within 1 week. It's been a little bit shorter. What we are seeing is that the buyers, again, after FDA has come in and swabbed the equipment, don't want to buy any subsequent product that came off of that harvester. So we're seeing those harvesters parked and not being used again until an FDA sample comes back negative. All right, so what we've seen in California and Arizona, where sampling has happened so far, is that teams of 3 folks in FDA come out in full Tyvek suits ready to sample, including hair nets and beard nets. And that includes a note taker who does nothing but stand there with a clipboard and takes notes of all the samples being done. They have been swabbing zones 1 to 3. They're spending a lot of time and a lot of attention on zone 2, under things, and then for things that have been on the equipment like alligator clips, all right? They've made comments about hoses touching the ground during that sanitation process, even if the nozzle and the head of the hose were not touching the ground. So literally commenting on just the fact that I have pulled a hose from my spray rig over to clean and that hose is sitting on the ground has been commented on. I don't know what the fix is for that. I don't know if it needs a fix, but there's been comments on it. They've been collecting up to 78 swabs, not the 60-some they originally said they would do. And the events originally took as long as 8 hours. They've gotten faster. They're down to about 3 hours. So yay, FDA is getting faster. So far, they have completed the sampling in California, and they are almost done the sampling in Arizona. They have not had any Listeria monocytogenes or E. coli 0157H7 detected. They will start Florida sampling after they're done in Arizona. We suspect that'll begin in early February. All right, and as far as we know, no even presumptive Listeria monocytogenes or E. coli 0157H7 have been detected. Now, the growers know FDA is coming to do this swabbing. So if you had FDA coming onto your facility and you knew they were going to come and swab one of your harvesters, do you think you might do anything differently to that harvester? Maybe we'd do some additional cleaning and sanitation that might not be happening. Yeah. I mean, that is my recommendation to everyone is to, I think nuclear clean was the word that I've been using, and maybe more than once. All right, that's where we are so far. Now, all right, Florida's plans follow what they've been doing. Again, we're going to do this deep cleaning, and we expect them to come in late February, or late January, early February. And the farms are being notified by FDA. So I think FDA's intent of what they wanted to do in this study is clear, right? Obviously, there was a problem, and they want to know how widespread the problem is. But their approach to this problem, right, was a sledgehammer, when maybe a finishing hammer might have been a better approach. Let's see how bad the problem really is. So I am working with a team, Channa Rock, who's out of the University of Arizona, Trevor Suslow, retired from UC Davis, and then Justin Kerr, who's a consultant in the industry. And we are working on a project funded by the Center for Produce Safety to look at harvest equipment and do a data-informed consent of what is clean, right? How clean is clean, what is clean, and how do we define it? We're focusing on 2 different types of lettuce harvest machines in California, Arizona, and Florida, a 3-point belt harvester, and then a self-propelled harvester. And within our project, we are going and we are collecting swabs off of this equipment at 3 different time points. We are collecting 25 swabs before the cleaning happens, so after you've harvested, before you've started cleaning. We're doing 25 swabs post-clean, so after you've done the cleaning, but before the sanitizing happens, and then we're doing 10 swabs after sanitizing. All right, we have broken each of these harvesters down into 5 different areas, what we're calling Area A, Area B, Area C, D, and then E. Okay, we know from both Joel's root cause analysis work and from work that Trevor and Channa had previously done, looking at indicators on harvesters, point E is where we expect to find a problem if there is a problem, right? This is a hard area to get up and clean. And we've seen, as we've been in the field, some very, very interesting ways that people get into that area that might cause OSHA complaints. All right, so section A includes a drive roller, conveyance belts. B are self-guided belts. C is a spray tunnel. If there is a spray tunnel on the equipment, right, not all equipment has a spray tunnel on it, but if it is, that's what section C is. D is the incline, and then E is that collar belt, chute, collar mounts, all that kind of stuff up on the higher equipment. All right, this is what we're looking for in our study. We are pulling an ATP reading, again, because that's an easy real-time check that could be used in the field. And then we're looking at aerobic plate count, generic E. coli, total coliforms, and then we will enrich for Listeria species if that is something that the grower or the harvester wants. Certainly not everybody has opted into that, but we have made that available to them. We're also collecting a huge amount of data as we do this in terms of how that equipment is being cleaned and sanitized. So what type of detergent, what type of sanitizer, are they brushing it, are they not brushing it, how long do they brush it for, what's the temperature going on, total gallons of water used. We've gone so far as to even label some of the brushes so that we can tell how long they're actually being scrubbed for versus how long they're just being held for. So we're collecting a ton of data. We're all collecting a bunch of metadata, like what's been harvested on that equipment, what kind of weather events have happened before that is harvested, where the harvester is stored between when it's cleaning and used, what the water source is, and then looking at sanitary design that Elena's going to talk about after and ranking on it based on age, design, and cleanability. And so we are collecting all this data. Now, I wish I could stand before you today and present this data, but we are actively collecting it, so hopefully I will soon be able to present it to you. Our goal is to figure out where the industry is right now in terms of cleaning and sanitizing across multiple regions, and then to be able to use that real-world data we've collected, again, in these different regions, in these different areas, to inform industry practices and to really identify any common gaps there are, or things that seem to be working well or things that seem to not be working well, and to make recommendations for continual improvement and preparedness for future audits or the inspection. All right, so you might be thinking, I'm not a leafy green grower. Why would this be important to me? Well, Listeria outbreaks, like I said at the beginning, are becoming more frequent. And a similar outbreak or a root cause analysis in just about any commodity at this point might trigger a simple sampling event. Even if you were never linked to the problem, and I'll point to us in Florida being part of this sampling event that's happened, and even if you're only a very small fraction of the industry. So I think we all just want to be aware of this to know that this could happen to us. And then I'll leave you with these questions to think about your own harvesting equipment if this was to happen to you. How clean is clean for your harvesting equipment? How do you define clean? When was the last time you actually went to watch a cleaning and sanitation of your equipment? All right, I think not often is what we hear a lot. How does your SOP, those standard operating procedures your audits require, verify clean? Does it include a pre-harvest check of the inspection, or is it really just what does your SOP look like and then what does your records look like? Do you actually go out and watch those practices happening to make sure they're happening the way you say they're happening in your SOPs, or are you simply looking at the records and trusting that everything else happens? I would encourage you to go watch practices to make sure that what's happening is what you hope would be happening. And then would you be ready if this happened to you? And so that's where I'm going to end today. This is just a picture of Chan and I with one of the harvesters we were at in California. And I will gladly take any questions at this point. Has the FDA what? The farms that they're going to in Florida are aware that FDA is coming to them. They have not publicly said to anyone what farms they're visiting. Have I? Yes. Yep. Yep. Yeah, no, I mean, they have not even identified the 3 processors that they are working with to identify farms. Unlike California and Arizona, though, right, Florida's a bit of a different situation where our farms would be selling into at least 2, if not all 3 of the processors, right? We're a lot less vertically integrated than what happens in California and Arizona. Yeah, good question. Kelly? Okay, so Kelly's question here is with the harvester linking to Iceberg, why did FDA go after romaine? I don't like to try to understand why FDA makes decisions they make, but I would say it's a historical bias based on right, all the outbreaks romaine I've seen in the past. In Florida, they're not just sampling romaine, they're doing romaine and cabbage. So, but in every other state, they've just done romaine. It's still not Iceberg, no. And I don't know why. Yeah. All right, any other questions?
All right. So I'd like to introduce our next speaker. You good? Yeah. I'd like to invite Elena Rogers up to speak. Elena is with North Carolina State Extension. And as Michelle kind of mentioned, it's a talk that ties in nicely to what Michelle was talking about. Elena is going to discuss some problems in packing houses and equipment sanitary design and how to really make sure that you're getting in and cleaning spaces you need to be cleaning. So Elena.
Thank you. Thank you, Laurel. I appreciate being here and having this opportunity to share with y'all some of the work that we have been doing as we visit growers. And so as I got tasked with putting this together, I really wanted to not just share with you what sanitary design is. I think we've all heard that term. I kind of think about this as one of those books in the Bible that no one likes to read because they don't understand what it really means. So hopefully today we will kind of take that concept and apply it to where can we use it and how can that benefit you, and what are some homework that you really need to be doing, especially in the off season, to really take advantage of sanitary design and improve your operations. So when I started working on this, it was natural to me to come to Lynette Johnston, who is our extension specialist at NC State, and we basically kind of brainstorm a bunch of ideas, and talked about the experiences we've had as we have gone to farms, and especially in the last couple of years. And so a lot of what you're going to see here is reflected on that, okay? But let's get started with background. I kind of want to just briefly go over some facts, we know, okay, that pathogens move into packing houses, and I'm only focusing on packing houses for this presentation, okay? So we know that they come in through different means. They come in through workers' boots, they come in with equipment, forklifts, the harvest containers, that come into our packing houses. All those are bringing in pathogens, okay? That is a given. We know that probably one of the pathogens of most concern to the industry, Listeria monocytogenes, loves to live in packing houses. We know that's where it loves cool, damp, dark spaces, okay? So think about how many spaces probably meet those conditions in our packing houses. And then we know that other pathogens are going to survive, actually some of them for quite extended periods of time. And so if we are not cleaning and sanitizing our equipment, our food contact surfaces, we are going to have to deal with the repercussions of contamination. And so a couple of things on cleaning and sanitation, okay? Whether you have been doing cleaning and sanitation for a long time and you have a well-established program, or you are just a beginner in that world, we focus on training, we focus on getting the equipment, getting the right products, we're getting all the cleaning tools, setting up, we now have to pay more for those shifts where our cleaning crews are working. And we get caught up in all that. Okay, we think about our verification, environmental monitoring, which is, a requirement for in a lot of audit programs. But what about sanitary design, okay? And so, but what if, okay, we've done all these things, but what if the areas that we're actually cleaning, or the equipment that we're asking our cleaning crews to work on, cannot be cleaned properly, okay? It just cannot be cleaned properly. And so we're asking them to do this. And what comes to mind is some of you might have remembered Mr. Irvin Lineberger. He was a berry grower in North Carolina, and he was amazing. And he has this massive hand washing stations that go out to his fields with his harvesters. And he would say, if I'm going to expect my workers to stand in line for 10, 15 minutes, do you think they're going to wash their hands? So he had the biggest hand washing stations he could get because he wanted to make sure his workers had everything they needed. And so again, if we're asking our cleaning crews to come and work and clean and sanitize our areas properly, what if those areas have problems to begin with? The other thing that I want to kind of, as we go into this conversation is, what if we do take the time to assess and fix the problems we find in the off-season in our equipment and packing houses, okay? What if we start looking for where pathogens may be hiding? What if we do start actively looking for niches? What if we start looking for the places that our cleaning crews miss? And actually this time, after your season's over, if you did not do a good final cleaning and sanitation shutdown, this is the perfect time to go in and find where little seeds have been congregating, where organic matter has been, this is the perfect and ideal time to do that. So how can we do that? We can do that by incorporating principles of sanitary design and hygienic design. And basically what that is the engineering and design aspect of equipment, and when you lay out or when you design and build the packing house, how can you build it so that it's easily cleanable? How can we build it so that we minimize the, niches for contamination? On the other hand, most of us are not going to build a brand new building. We're going to have, we got a building, we leased a packing house. So how can we improve the buildings that we have? On the other hand, how can we look at equipment? And there's some distinctions I want to make between new and used, and but how can we make sure that the equipment is set up in a way, or was designed in a way, or that we can take advantage of it, or that if it's not, because no piece of equipment is perfect, how can we make sure that our employees are aware of where the problems are so that they take extra time in cleaning and sanitizing those areas? So what are some issues that we see in the produce industry, okay? So this whole concept of sanitary design is not new by any means, and I'm going to show you some resources that come from the meat and poultry industry, that come from food manufacturers. This is not a new topic by any means, but it is hard to find documents or resources that are specifically, designed for the produce industry. So I will show you some of those. So just want to say, this has been an area that we have been very slow to adapt. I remember 6-7 years ago reaching out to equipment manufacturers and then being like, well, we're not interested in changing the way we're doing equipment because our growers are not going to pay us more for, changing to some of the sections to stainless steel, or, improving the sanitary design. I think this is changing. This is definitely changing. We see our manufacturers more open to that. But we also have a lot of old equipment that was built with materials that can simply, maybe they might be able to be clean, but they cannot be sanitized for sure. We still see a lot of wood. There are some parts of the country where we don't, but there are other parts of the country where we do see quite a bit of wood still. And then the other thing is that most equipment, no matter if it's new or used, it will have issues, okay? It will have issues, it will have issues, so we need, unless we do an assessment, we won't know where those problems can be and how we can fix them or address them. The other thing is, as we look at it more specifically, packing houses, a lot of times the materials that we're using for the activities we're performing are not adequate. So here's like a tank that gets sanded and prepped and painted every year, but that's a wash tank. So that wash tank, as soon as you add a sanitizer, is going to rust every season, okay? And that is a problem, right? So painting versus no painting, the whole debate, okay? Maybe you can get away with it on some dry areas. Not ideal, but what if water is in the mix? That is probably not a good idea at all. The other is drains. Just think about drains and the fact that we have all kinds of drains. What do drains do for us? Drains are like the toilet to a facility. So being able to understand how to manage those drains, how to maintain them, how to clean them, super important. The design and placement in relation to equipment, okay? You probably never want to have a piece of equipment sitting right on top of your drain, okay? Especially if you're in a wet area. So just things to think about, okay? I'm just kind of showing you some. And then the other thing is, does the equipment layout favor cleaning and sanitation activities in a timely manner? We have a lot of packing houses where everything is so tight that you can barely move in there. How can you expect a worker to come in and actually be able to clean and sanitize those areas on a timely manner, efficiently, if they have no room to move, okay? So for that, and because of all the challenges that I presented to you, we have been actively looking for resources we can use with our growers. And here is one. I have some hard copies. This is like an excellent booklet, and all the examples most of the examples I'm going to provide come from here. This is something you can access online by following that link. This is through Food Northwest, so it's a food safety group that obviously from the Northwest, out of Oregon. You do obviously have to provide your information, that's for them, but they are all about education. They send me the hard copies, so for the farms who are here, please take a copy with you. But you can download this book and you can use it, and it is a fantastic resource. I'm about to show you what that looks like. The other thing is that you don't have to, as we get into sanitary design and as we start doing these assessments and applying these concepts, you don't have to like reinvent the wheel. This is a resource from Chris Callahan. In a minute, I will give you a QR code for all his materials. This is something you can print. It's a 2-pager that you can take, and you can apply this to every piece of equipment in your facility and to the building itself. And you can then get ratings and identify areas where you need to make improvements. I will say, alongside with filling these forms, probably the most helpful thing for me is to take pictures and to take them in order so that you can go back and remember where's the problem, so they can see what the problem looks like, what equipment do you need to repair, what parts you need to order, what parts you need to get, and so that you can do those repairs in a timely manner before the next season starts. So here are 2 fantastic resources. Chris Callahan out of University of Vermont has devoted basically the last couple of years to develop a good number of resources specifically for produce farms. He does work with smaller farms, being in Vermont, but the principles are the same and you can apply them to any, operation. And then on the other side, I have the food safety equipment design principles, and these are from the Meat and Poultry Education and Research Group. And this is a document that has been around for a while. I think it was updated in 2021 the last time. It is excellent, and you can also print that document and use it. So very briefly, I want to show you what the sanitary design principles are. And basically, and I just want to show you a few, okay? So Chris Callahan, for example, has make sure that the areas are visible and reachable, that you can actually see what you're going to inspect, smooth and cleanable surfaces, no collection points, use compatible materials with cleaners and sanitizers, prevent contamination, just like making sure as you're thinking about the layout of your building and thinking about equipment and your activities in there, okay? So this principle, you obviously would use this checklist to apply these principles and figure out where you need to fix things. But I do, hold on, okay, sorry, here it is. But I do want to show you, if we follow this book, which we feel, so this book was created to help line workers understand sanitary design, okay? And that's why we like it so much. And I just want to show you how, there are different groups that have these principles. They are all very much alike, very much, just probably things are phrased a little different. But the Food Northwest, who created, who published this book, they have 4 principles that are pretty simple. One is being, making sure areas are accessible for inspection, accessible for maintenance, for cleaning, for sanitation, that you have no niches, so nothing, areas where things can hide, where, and again, we're thinking of bacteria, so these are little microscopic or viruses, but areas where it's obvious that water can get trapped, where organic matter can get trapped, and where that can create a problem. The other thing, no collection points, okay? And the last one is eliminate or minimize hollow areas. So I just want to briefly show you, what are some of the things that are in this book, okay? The principles and how clear and how simple they are. This is something you can use, whether you're the food safety manager, or, the farm owner, you can apply these principles to your equipment and go through it. And just because of time, I'm not going to go through each one of them. I'm only having 30 minutes. But here, I want to kind of talk about a few examples of things. So we do have, this is one of our conveyor belts that loads into our amazing optical sorter. And yes, it does look nice. It looks pretty clean. But can you access the sides? It would probably take me quite a while to be able to pull those sides out and actually see what's on the side of those belts. So think about accessibility is a big thing, but on the other hand, there is other equipment, that maybe it was not built with sanitary design principles in mind, but that once you get trained and you train your employees on how to take it apart and put it back together correctly, you can actually do some, pretty impressive inspections and be able to clean it and sanitize it properly. On the other hand, one other thing I want to mention is principle 2, no niches in zone 1 and 2. I think that's pretty straightforward. And hopefully we start moving away, zone 1, we really want to be careful, but we still find belts like this, right, that are heaven for pathogens to live and thrive. So just kind of, again, think of what are all these things and how can you get rid of them in your food contact surfaces and around food contact surfaces. Here's what principle 3 says, and these are for no collection points, so these are examples. Maybe as I move forward, and again, because you will have access to these lists, I don't want to take a lot of time, but, we oftentimes think that, like these are not problems we have anymore, but you still find a lot of equipment that has been retrofitted, a lot of equipment we're just trying to piece together. And you still easily find collection points. So getting rid of those and fixing them, that doesn't have to be that hard. On the other hand, this is like a bin loader. You can see where we've come a long way in the produce industry. We do have better surfaces now that these belts can be easily cleaned and sanitized. The other, another example, and this is more an example that we would like to share, for example, with equipment manufacturers, is that anything like horizontal members, for example, should be rounded or angled to prevent building of water and organic matter. This is actually a small sorter, sorter, and all the product falls in the bottom, and this is like just perfect heaven to collect, juice and all kinds of things that bacteria like to thrive on. The fourth one and the fourth final principle is eliminate or minimize hollow areas, So how can we make sure, especially around zone 1, that we are not, what might be a better solution? And we still see a lot of rollers. We see tubes on zone 1s. Belts can be a better, option because these can be probably better cleaned and maintained. However, being able to make sure we are accessing, that those sides of those units are not impossible to open or nearly impossible. The other thing, Trevor Suslow always says, if you look at all his, threads, bolts exposed, around zone 1 areas, that is the one place when you go and do environmental monitoring, that's where you're going to find them. Here's more pictures on that, Look at those areas and see where things are collecting. Again, this time of the year, If you go and do those assessments last year, I think in the winter, Lynette, and we spent some time doing this, and it was amazing the number of pictures we have where you could tell that the cleaning crews never got to. Here's other examples. I will actually just wanted to use this one with the red tape to say stickers, duct tape, notorious for, niche sites that can be easily removed from all equipment. And then we have so many different types of belts, but the blue belt in the middle, once they start, first of all, unless you have a good foaming system to clean them, you're not gonna clean them and sanitize them, even attempt to that. But if you do, the wear out that they get on the bottom, you have to be able to inspect those things to be able to acknowledge the problems. But moving on, in case this seems like, oh my goodness, this seems a little complicated. One of the things I love about this group and when they put together their materials is that they came up with the 3 principles, the 3 summarized principles that we can use with all our line workers and anyone who works on cleaning sanitation, okay? And we actually have some posters they sent me here of this slide, so if you would like to take that too. But basically, the first thing is like, if you would not probably eat out of it, that might be a better way to put it, maybe that area needs to be, you need to rethink that area. Is it really clean? And even if you did make your best effort to clean it, if you still wouldn't eat out of it, there is something to be said about the product we're running in that line, okay? So maybe that is how we define clean, right, from a 101 perspective. Could it ooze out? Could it be that we have water dripping, that we have something flowing, oozing? Would it be that there's juice coming out of it because we ran product and we know that when we run product, there's going to be product that has issues and juice is going to come out of it. So that is the second principle. And the third principle is like, if I was a Listeria individual, where would I hide? Where would I hide so that even if someone is coming in and cleaning and sanitizing with brushes and foam, they wouldn't find me? Okay, so if you can use those 3 principles, if nothing else, I think you can accomplish, a lot more than you've been accomplishing. And I do want to say, sometimes, and I didn't have time, I didn't feel I had time to show you all the pictures I have, but sometimes the changes can be pretty complex. Sometimes you have to decide, hey, this whole packing line, it's seen better days, and so at least let's prioritize how we're going to replace the equipment because we know that no one here has unlimited funds, right? But at least where do we start so that this year we can take care of this immediate area and then take care of the next area and take care of the next area? And what are some things we need to do? Maybe we need to rethink and going from wet to dry operations. If we, there are things we need to really be thinking about as we fix problems. But on the other hand, there are a lot of changes that are not that hard to make, and they just haven't been made because we are not taking the time to maintain and to assess our equipment in the off-season. How many times do we see growers put a cover over their packing lines, right? And you have all the good intentions to come a month before you start running and uncover it and work on it. But a month is not a lot of time when you have a million things going before harvest day. So taking really the time to work on those assessments right now when you're hopefully not doing much is really important. I want to basically encourage you, okay, because I knew we have 30 minutes is not enough time to cover this very complex topic, is to learn about sanitary design. Whether you're in North Carolina, we will be doing cleaning sanitation workshops this year. We will be covering this, okay, and we will be doing some workshops, but talk to your state. But you need to learn, and there are really good resources. The resource from Chris Callahan has like 5 hours of footage from field days he's done on this topic, okay? So learn about it and how can you improve your operations. The second one is assess equipment. Assess now, okay? Take the time now and do equipment and don't try to do all your equipment in one day. Take half a day and do one piece of equipment. That way you can actually pay attention to the details and look for the problems. And then do your building, your whole building, your drains, your coolers, all that in a different day. The third one is prioritize repairs, which I just talked about, and set a schedule. Set a time for upgrades to be made. And make sure that you have time. With the supply chain and the way things are, you might not be getting parts for a couple weeks. It might be that you need to order. I know growers that have ordered new rollers, and it's a month before they are even, might be a couple of weeks before they even get in contact with their supplier. So, and then share your plans with a knowledgeable person. Some final thoughts based on visits we did this past year. If you are operating a packing house, I just mentioned assessments, so I'm not going to say that. But my question is going to be, did you clean and sanitize your equipment and buildings at the end of the season? Did you do a thorough cleaning and sanitation? If you didn't do that, you need to do that. But before you do it, document this. This is when you a great time to take pictures. The goal should be that we clean and sanitize our zone ones after every use. And there's many excuses why growers are not doing that. I talk to y'all all the time, and I'm like, why are you not doing it? We run out of time. It's too difficult. The person doing it didn't want to mess up the pumps, and it's like, well, you can cover the pumps. Some of these issues are training, but the reality is, like, why are we not cleaning? And a lot of times we're not cleaning because we can't access the areas we need to access. If you are retrofitting a packing house, and this is one I want to mention and be very serious on, do not wait until you have made all the changes over the winter and wait until everything is said and done to call someone from a food safety team to come see what you've done. Share your plans before you even do that, or early in that process, because a lot of the mistakes or a lot of the things that could have been fixed in how you include sanitary design principles, you could have added those when you were building. The investments you make, how many times does a manufacturer say, hey, do you want, we're building 2 lines, how far apart do you want them? How big do you, or when you're even thinking about laying a packing house, laying concrete, how big you make this packing house. And what do we normally say? I want to save money. I want the smallest. I don't want it to be very big because I don't want to pay more. But guess what happens at the time when it's time to clean and sanitize? Your workers can't even get around to do those options. And there's not even enough space to put all your packaging materials and all the things you need. So please make those connections early if you're going to retrofit a packing house. And if you're going to buy equipment and you're going to buy used equipment, and I know oftentimes we buy a piece of equipment and we just wait till it's delivered and then it sits somewhere for a couple of days. These assessment needs to be made on used, especially used equipment. You need to think about, what was it used for? Has it been cleaned? What are you bringing into your packing house with equipment that was used? You need to make sure, especially that's an area where I would make sure I'm doing an assessment. And last but not least, if you're buying new equipment is not perfect by any means. So talking to your manufacturer, and I know the answer you're going to get from most manufacturers is like, I don't know how to clean it and sanitize it. That is your problem. That's not mine. But then you need to work with a cleaning sanitation company, experts that know how to clean. And if that piece of equipment cannot be cleaned, you need to rethink the equation. We are, for some time we have been looking at how do we clean electronic equipment, because optical sorters and all that. There are products out there. There are reduced moisture sanitizers you can use, cleaners and sanitizers. Most of the industry doesn't know about it, but the reality is a lot of electronic equipment is really hard to clean and sanitize. So with that said, I just wanted to share one last or a resource, okay? Part of the reason we sometimes don't talk a lot about sanitary design is because we just kind of like, well, we're just going to try to do our best, and if we can't clean it. But if anyone is really serious about this, there is a wonderful Listeria Management Certificate program. It's an 8-week course. It has 4 live sessions and 4 recorded sessions through the IFF, through the International Fresh Produce Association. They offer it in English and Spanish, and in Spanish it only costs about $100. It's meant to be designed for line workers, supervisors. This is a great way to understand why sanitary design is so important. That sanitary design is a whole module on this. So I know I only have 30 minutes. If you need to get a hold of us, please, like both Lynette, anyone on our team will be glad to help you with this. But we just want to make sure that, you recognize that this is a tool that you can use. And I have books here in the front. So for all the farms that are here, please come get one per farm. And, we also have some posters. So, but with that, thank you. I don't know if you have any questions.
Oh, thank you. All right, well, I'll go ahead and introduce our next speaker. So Camila Rodriguez is an assistant professor and extension specialist at Auburn University. She's going to be discussing some of the food safety hazards that are frequently encountered or maybe overlooked in controlled environment agriculture. So Camila?
Thank you, Laura, for an introduction. It's a pleasure to be here today, and I'm shifting gears a little bit from sanitizing, not much, but from conventional growing systems. So today I'm going to talk a little bit about, I'm too short, let me see if I can. All right, I think it's better. Some mitigating food safety hazards in CEA. So we all probably familiar with previous news that when the outbreaks that have been raised with E. coli and salad and romaine lettuce, there was a catch on whether indoor ag or vertical farming or hydroponic, aquaponic were going to be safe. So there is in the news a lot of, information coming whether those systems were safe because there is a lot of outbreak and a lot of recalls in the lettuce, especially lettuce grown outside. So you probably saw some of those news saying that vertical farm could be the mitigating food safety concern. Lettuce grown hydroponically could be E. coli proof or salmonella proof. And so there are a lot of news out there. But in 2021, there was the first documented outbreak linked to indoor grown lettuce. And that was due to salmonella on prepackaged lettuce. There was a grow on an indoor farm. And at the same year, leafy greens were also recalled due to Listeria contamination, Listeria monocytogenes contamination. Then the next year, there was another recall with fresh lettuce that was grown indoor linked to salmonella. And 2023, there was another recall, a big recall from fresh lettuce grown indoor with concerns on Listeria monocytogenes. So what is next? So, more is coming, and then we acknowledge that more investigation are coming, and then, it's not that just because it's just started to happening now, but this is an industry that is growing, and it's just to show you this section of the agriculture is not immune to contamination. So we need to keep an eye on it and take actions, what is going on and where we need to look at into, implementing preventive measures to avoid those issues. So what are the differences? What are the food safety concerns on those areas? So specifically for those that grow aquaponically, it is a shared culture between fish and the plants. So there's a lot going on that system. There's a huge microbial community in there. And if you think about the shared culture with fish, and if you would think it's the same thing as using a pond water, but it is a closed system and they use recirculating water. So it is another level of concern in here. We have complete different facility and design. They're pretty unique. If you think about outdoor compared to indoor, and even those ones, if you think about vertical farms, they can be completely different, and they have complete different designs. So all of those particular operations, they are very unique. So that's why it is very critical, for us to create some, or to come up with some identifying critical points of where contamination can happen. Again, different environmental conditions. We have a more controlled environment. We have a lot of those places, high humidity. We have a temperature control. We have a more, what they say, sterile or cleaner environment, what that means, right? So we have to think about it. Constant water movement, we know that all water is a higher risk. So we have water constantly passing through the system. And again, humans and cross-contamination is a big concern. And if you see some of those practices, then you can think about, well, it's okay because to step it in and on top of water tank or going inside. Sometimes we see people inside the fish tanks, and then it's a normal practice, you know, but we think about how you can do this safely, what measures that can be taken so people can go and work and do their job. And if you think about, you know, animals and pests, so those are a concern. Reptiles, they can carry salmonella and they can transfer to the plants that are growing there. Rodents, that you can easily find them on those operations. And cleaning and sanitizing, I think we had enough this morning to think about, you know, about cleaning and sanitizing, especially those rafts that have been used for months. You think water accumulating around, you know, think about biofilm forming of those crusted areas. You know, sometimes redesigning is not the best option. You can think about around this tape that could have bacteria accumulating on there. And also, this is an example, what I've seen, it's a carpet inside a vertical farm. So not practical at all. So we can imagine what can the traffic and what can bring in. It's not easy to clean. So my group is doing both research, integrating research and extension to, you know, try to address and mitigate those risks for control environment. So I'm talking a little bit about my research that I'm doing here. So I am investigating and exploring mitigation strategies to improve the safety of indoor grown produce. So I'm working specifically, this is some sort of basic science, so we are trying to understand, so, and then trying to understand some of the sustainable and methods that can be used in the future. I'm just trying to prove the concept here, not, this is up to the companies later developing products. But I'm using bacteriophage. So for those of you that might not remember bacteriophage, we studied them back in school, you know, those phages or phages that they call it. So those are viruses that they're abundant in the environment and they target bacteria specifically. So they're environmental friendly, they are not harmful to human, animals, or plants. And they can be a very they can be a grateful tool for, you know, being implemented on a system like that. But again, it has to be carefully watched because it is a case situation. But I'm working on it to see if this could be an option in the future for growers to mitigate or, you know, prevent or controlling some of these microorganisms that are in the system. We know those systems are difficult. You don't throw chlorine into the water because it's harmful to the plants. You also don't throw any chemical in the water if you're doing aquaponic because you want to keep the microbial community very well established. So what are the options that we can explore here? So I did an experiment. It is a laboratory setting experiment. So I'm just testing the concept of using recirculating water system in a small setting and putting the plants in. So I was using nutrient solution from hydroponic and aquaponic. So the aquaponic we actually collected from our research station at the day. And we are using a phage cocktail. What is a phage cocktail? It's a combination of 3 or more phages. So we avoid some sort of resistance to the bacteria. And again, salmonella. So we explored that. We collected water periodically up to 6 days, and also plant parts. And what we saw is that for both hydroponic and aquaponic, using 2 types of salmonella, the salmonella went down really quick after 2 to 3 days, and they were below the limit of detection up to at 6 days. So showing that the phage cocktail was very effective in controlling salmonella in both aquaponic and hydroponic nutrient solutions for these recirculating water systems. Again, this is just a prototype and this is a very pilot study. Our aim is to explore and do a more thorough, consistent study to explore how that's going to be on a fully established system. But when we looked at the plant part, so we separated them leaves, roots, and the pods that they grow, so we use rock wool. So what we saw that was interesting, we remember the last slide, it was both hydroponic and aquaponic, we had a very consistent reduction on salmonella over time for both aquaponic, hydroponic. But then here, we only saw levels reducing to below the limit of detection for the hydroponic nutrient solution, but not much for the aquaponic nutrient solution. So phage was very effective controlling salmonella contamination only on hydroponically grown lettuce and this experimental design. So it means that we need to take a look on the microbial interactions of what is going on in the water, you know. So that could be maybe a concern, or why is salmonella surviving and not being attacked by phage under this on aquaponic. Maybe phaging is targeting other organisms in the water, or you know it's overwhelming. It's an overwhelming system, and then salmonella is not being targeted by phage. So this is something we need to be exploring, and then gave just a hint on what we could be doing for further studies. But I think it's still pretty interesting to see, at least in the water, is controlling really well salmonella, and it could be an option in the future if growers are, you know, using this kind of system and they want a more sustainable approach on controlling salmonella. And the other part of what I'm working with, especially with University of Georgia and Alabama A&M, we have a project that we are developing a curriculum, specialized curricula for indoor ag. So for this is a USDA NIFA funded project. The first part, we conducted a needs assessment survey. We collected information from the industry, from growers. We are now in the phase we are working closely with the industry, with growers and CA operations, and how we can design and how we can put it together a curriculum that will fit to their needs. And also they still need to be inspected by the state departments. They still need to go through GAP certification. They're still following the same standards as the conventional practices. So how they can, you know, fit into this, and what are the uniqueness for the system, they need to be getting training and look it over. So for the training, we are putting together a curriculum that will be, we are still working on the modules, but probably a half a day training. We are also going to be testing whether working in person or hybrid or virtually. So for that, we have facilities in Auburn that we can host trainings and on-site tours, and that's probably going to be starting happening next year. But based on what we've done so far, we were able to start looking at some critical points of contamination. You know, this is pretty much based on what is in the GAP, as what in the produce safety rule, working on working health and hygiene, soil amendments, agriculture, water, animals and pets, and cleaning and sanitizing. So just to take a look at in a few specific areas, this is going to be just a sneak peek on the curriculum we were developing, and there will be more complex slides, and then we are going to digging into those areas. But just an example, for worker health and hygiene, we need to be, you know, advising them that they need to be cautious that contamination can happen at any time, even during seedling, planting, pruning, and harvesting. And those are different and unique techniques. So if you think about those, when they're planting and seedling, they're putting the racks on a raft of water flowing constantly all the time. So they need to be overlooking at the water that is in that moment where, you know, plants are germinating, and also cleaning around this area constantly. What is the frequency of cleaning as well? And when we talk about workers training, you know, how they're trained to handle produce during the production, or even when they're harvesting, if they're touching the water when they're harvesting or not. Again, handling methods to prevent cross-contamination. One thing we identify through our assessments and working with the growers is that the safest method to harvest lettuce from those rats is one hand they touch the one hand that they touch the produce, the other one that they touch the water. They don't cross with those hands. So one only touch the produce and the other one only touch the water if necessary. So some of those practices need to be passed along, and they need to be conscious about that. And visitors, those places are, they're agritourists. They want people come in. Some of those places, now some others are very proprietary. They don't want people inside. But again, a lot of those places, they get visitors. So they need to have policies for visitors, and they need to, be aware that visitors can bring contamination from outside. And hand washing, again, it is important. Just because it looks clean, it looks like you're wearing gloves and boots and hair nets, it doesn't mean that, it's not, it doesn't mean that you are clean. And you still need to practice the hand washing and keeping training documentation. So just an example, hand washing stations that can be as beautiful as this one that we have in our vertical farm, but it can be also very simple. As long as it's close to or nearby the operation, that you don't take the risk of bringing anything inside after, wash your hands. So it can be very simple. Just make sure that you're using clean water, soap, and then disposable paper towels. And the soil management, when we talk about soil management for indoor ag, we don't talk about manure, we don't talk about soil itself, we talk about media, growth media. So what is the important to think about is that the growers are buying from certified suppliers. Make sure you're getting those media and storing them properly. So those media can, their research showing that they're not sterile. They have a lot of bacteria. They have a very solid, consistent microbial community in there. So make sure that you're buying from a certified supplier. And water, again, water is it's a constant problem. It's unavoidable in this area. In this area, it is where the nutrient is incorporated. So again, it's a major contribution to fresh produce contamination. It needs to be watched carefully, and the FDA consider aquaculture. They address the water that is used for aquaculture and the same water quality and standards at the PSR subpart E, which is currently proposed and pending finalization. So again, they consider the water that is used from aquaponics that is recirculated in the system as the same quality as the surface water. And again, think about those. Growers don't use chlorine in the system. Chlorine is toxic to the plants, but they use hydrogen peroxide. So we have a different approach here. But again, using sanitizers that are EPA approved and for its intended use. And again, we have different risks depending on the system they're using. When we're using biorafts in the deep water culture, we have high volumes of water, and then we have splashing and all of that. And we use NFT, we have lower volume of water, and versus the Dutch buckets that we only have, fruits hanging on the vines, and water is just dripping on the bucket. So we have different levels of risk depending on the application method that the water use. And then don't forget the water that is used for evaporating cooler system. Those, some greenhouses, they have some evaporating cooler systems, and you have to watch for the water quality of that one as well. So because it's overhead water, overhead irrigation, let's say, so it's directly contact the edible portion of the plants. So we have to watch the quality of that water as well. And as I mentioned, cross-contamination is a big deal here, especially with the aquaculture, that they share water with fish, so people are constantly inside the water. And I've been in places where only greenhouse for hydroponic, where people get into the deep water culture tanks and to move the rats around and everything. So make sure you are avoiding that water to get in contact with the upper part of the plants, with the edible portion. And again, pests and animals, we don't think about animals, cows or deers or those animals that are problem in the field, but we think about, you know, the small rodents and small animals that could be a problem inside the facility. So make sure that you have a pest control program that is very effective for your area. Again, birds nesting on the ceiling, you have a greenhouse or even a warehouse that you have to watch for birds. And again, pets are not safe at all. They can carry pathogens. So keep your animals, your pets, they're pretty cute, they might be clean, but again, they can be a problem for your facility. And adjacent land. Some of those operations, you know, they're urban areas, but then some of them, they're greenhouses in the farm. So even though you don't have problems with deers and cows, they're outside, you can bring contamination from outside to inside. And cleaning and sanitizing, again, I know it's difficult to look it over if you've been on a farm for aquaponic or hydroponic, you see biofilm and slime accumulating in all places and in all areas. And it is, you know, it's hard to say, oh, I'm going to keep this clean for every day all the time. But, you know, just making sure you do the maintain routine cleaning and sanitizing. Every time you use the rafts, every time you harvest, make sure that you clean and sanitize those rafts. If they're being used over time, you can change them. Make sure you cleaning and sanitizing the rafts. So that is you preventing build-up of microorganisms in the area. And facility and system design, and again, all these operations are unique. And even though they carry the same system, they can be very complex and different. So we might have a very high design greenhouse operation, but we can have this, you know, very simple but it's still effective system. So you have to look it over and then make sure that you are identifying the risks and taking measures to prevent contamination. And I think I'm being fast, but my take-home message is that every system is different and is unique. So workers training is crucial. They need to understand that where to identify the risks and how to take measures to prevent any potential contamination. And again, the CEA are not immune to microbial contamination. We are seeing this happening over the past 3 to 4 years, and it's not gonna disappear, and it's gonna be happening and again. So just make sure that if you have an operation like that, you have to take extra measures to, you know, identify the risk and work with your extension and work your local resources and see what you can do, you know, because it's relatively new to everyone, or everybody's still navigating through, especially for food safety. And it's we are all doing the best to help the growers and help them to, you know, be trained and then to get certified and then be inspected. And this is one fact sheet that if you want to get a little bit more information on a bit what I talked to, some of the risks on food safety risk on greenhouse for vegetable production, you just go Alabama Extension and check this out. And again, thank you, and I'm open for questions. I hope I've approached everything that it was that you were aiming to hear.